All right, well, in order to calculate this, we have to calculate the t-score. And so the t-score associated with this data is going to be, let's see, it's x bar minus mu times the square root of the sample size divided by the standard deviation. All right, so this is my version of the book formula. I've inverted and multiplied and got square root of n up here. So, and I call it t-star because it's a calculated t-score. That's my use of this. Let's plug the numbers in. I have 17.8 minus 18 times the square root of 30 divided by 0.2. And let's see what that works out to be. I think it's, wouldn't that be the square root of 30? Alright, so it's 17.8 minus 18 times the square root of 30 and divide by 0.2 would be, and it's a negative score because we're below the mean, we expect a negative t-score. So this comes out to be negative 5.48. Negative 5.48. Right, now if you turn to your book chart on page 651, I think, 650, and we're looking for how many degrees of freedom. Always one less for this chapter. Well, so far, one less degree of freedom. So the degrees of freedom would be 30 minus 1, 29. What I meant was one less than sample size. So on page 650, let's look at the line for 29 degrees of freedom. I go all the way across, and the highest number that appears is 3.40. 3.40. So where is 5.48? It's way to the right. And you know, again, ignore the negative. The one time in math you can ignore a negative sign. 5.48 is far to the right of this chart. And if you look at the top, the probability numbers means that the probability is going to be less than 0.001. So the p-value is less than 0.001. Okay, so now what would we conclude then? Very small p-value means we reject the null hypothesis in favor of the alternative. And so that's in a nutshell what might happen. All right, so let me go back to the book here and read part C, their part C. How could you design a study to analyze and the resulting data to see if the manufacturer has a right to the claim on the jar about net weight? Well, you would need to take a random sample, one with a large enough sample size to produce decisive results is probably what you would want to do. And what is that number? Probably about 30, but it could be less. And then you would perform a hypothesis test comparing the sample mean that you measured versus the null hypothesis. Okay, so with the fictional numbers, I did precisely that. And in this case, with these numbers, you would conclude that indeed you do reject the null hypothesis in this case. The data is significantly different. These two numbers are significantly different in a statistical sense, enough so that we would conclude that the jars of jelly coming out of this manufacturer are not 18 ounces of jam. They're actually less than 18 ounces in net weight. All right, so there it is. Problem number 25. Let's go on to another problem.